I run several Java Enterprise Server applications. I often wondered what are the best default JVM settings for a server application to start with in production. I read a lot on the web and tried several things myself, and I wanted to share what I found out so far. Links containing more information about JVM optimization are located in the description below this video. Use -server parameter. All 64-bit JVMs use the server VM as default anyway. The setting generally optimizes the JVM for long-running server applications instead of startup time. The JVM will collect more data about the Java bytecode during the program execution and generate the most efficient machine code via JIT afterwards. The -xmx -xms settings specify the maximum and minimum values for the JVM heap memory. For servers, both params should have the same value to avoid heap resizing during runtime. I've had applications running with 16 GB heap sizes without an issue. Depending on your application, you will have to try out how much memory will be best suited for your use case. Java 8 has no permanent generation or permgen anymore, but requires additional metaspace memory instead. This memory is used in addition to the heap memory we specified before for storing class metadata information. The default size will be unlimited. I tend to limit max metaspace size with a somewhat high value. Just in case something goes wrong with the application, the JVM will not hog all the memory of the server. I suggest let your application run for a couple of days to get a feeling for how much metaspace size it uses normally. Upon next restart of the application, set the limit to, for example, double this value, just to make sure. Additionally, you might want to allow the JVM to unload classes, which are held in memory but no code is pointing to them anymore. If your application generates lots of dynamic classes, this is what you want. The first option makes the JVM use the concurrent mark sweep garbage collector. It can do much work in parallel to program execution, but in some circumstances a full garbage collection with a stop the world pause might still occur. I've read many articles and came to the conclusion that this garbage collector is still the best one for server workloads. The option CMS parallel remark enabled means the remarking is done in parallel to program execution. This is what you want if your server has many cores, and most servers do. Normally, the garbage collection will use heuristics to know when it's time to clear memory. The garbage collection might kick in too late with default settings, causing full garbage collections. Some sources say it might be a good idea to disable heuristics altogether and just use generation occupancy to start a CMS collection cycle. Setting values around 70% worked fine for all of my applications and use cases. The first option, scavenge before full garbage collection, tells the garbage collector to first free memory by clearing out the young generation or fairly new objects before doing a full garbage collection. CMS scavenge before remark does attempt a minor collection before the CMS remark phase, thus keeping the remark pause afterwards short. To understand fully what these options do, I recommend you read more about the garbage collection in general. The first option here tells the JVM to unload classes which are not needed anymore by the running application. If you deploy WAR files to an application server like Wildfly, Tomcat or Glassfish without restarting the server after the deployment, this flags for you. The second option is especially important if your application uses RMI or Remote Method Invocation. The usage of RMI will cause the JVM to do a full garbage collection every hour. This might be a very bad idea for large heap sizes because the full garbage collection pause might take up to several seconds. It would be better to do a concurrent garbage collection and try to unload unused classes to free up more memory, which is exactly what the second option does. The option shown here will write out all garbage collection related information to a specified log file. You can see how well your garbage collection configuration works by looking into it. I personally prefer to use the Visual GC plugin for the Visual VM tool to monitor the general JVM and garbage collection behavior. When your JVM runs out of memory, you will want to know why. Since the out of memory error might be hard to reproduce, and you want to get your production server up and running again, you should specify a path for a heap dump. When things have settled down, you can analyze the dump afterwards. The date variable in the file name makes sure that the exact timestamp of the incident will be part of the file name. These options will help you to specify an IP and port for JMX. You will need those ports open to connect remotely to a JVM running on a server for tools like VisualVM. You can gain deep insights over CPU and memory usage, garbage collection behavior, class loading, thread count and usage of your application this way. Lastly, I would like to recommend to you the VisualVM tool, which is bundled with the Java 8 JDK. You can use it to gain more insights about your specific application behavior on the JVM, like CPU and memory usage, thread utilization, and much more. VisualVM can be extended with a plugin called Visual GC. It will briefly show you a very detailed information about the usage of the young and old generation object spaces. You can easily spot problems with garbage collections simply by analyzing these graphs during application runtime. Thank you very much for watching this video. If you liked it, you might consider giving it a thumbs up. If you have any questions, just put them in the comments section below. I will reply as quickly as possible.